right, so continuing with density. So water has a density of approximately 1 gram per centimeters cubed. A cylinder with a radius of 1 centimeter, a height of 4 centimeters, and a mass of 20 grams is placed in a swimming pool filled with water. Will it sink or float? All right, so the very first thing we have to do is find the density. And to find the density, what would we have to do first? We've got to find the volume, right? We don't have the volume here. We have the information. So we have a cylinder. Here's our cylinder. It has a radius of 1 centimeter and a height of 4 centimeters. And remember that volume of a cylinder is pi r squared, the area of the base, times the height. Right, so we're going to substitute in pi times 1 squared times 4. Well, 1 squared is 1. So times 4, our volume is going to be 4 pi, and our units were centimeters. So 4 pi centimeters cubed. Now we have our volume.
So when we're actually at problems like this, do you recommend drawing it out?
I do. Sometimes it's easier. Some problems are easier than others. But if you have a picture, it usually makes it easier to figure it out. All right, so we have our volume. How about the mass? What's the mass of the cylinder? Orange 4. Do we have no orange 4? Purple 2. What's the mass of the cylinder? 20 grams. All right, so how do we set this up to find density? Green 4. And don't forget your units. So 20 grams over 4 pi centimeters cubed. So just as a reminder, density is mass divided by volume. I think of DMV. No. All right, so now when we simplify this, we're going to have to divide 20 by 4 pi. Be careful, don't do in the calculator 20, a division symbol, then 4 pi, because what will probably happen is your calculator will divide 20 by 4 and get 5, and then multiply 5 times pi, rather than divide by 4 pi. So I suggest you just use parentheses when you're dividing by more than one thing. All right, so someone in their calculator, divide 20 by 4 pi. Can you say that one more time?
1.59154. And this was on big numbers for me.
So 59154. What follows the 9?
4.
We'll end it right there. And so that would be grams per centimeters cubed. Have we finished answering the question?
No.
All right, so we want to know whether it'll sink or float. How can we tell whether it's going to sink or whether it's going to float?
If it sinks, if it's going to sink, it's going to have a larger density.
It's going to have a larger density than the water, right? So it'll sink if the density is greater than the density of the water. And notice it says up here that water has a density of approximately 1 gram per centimeter cubed. So density of water is 1 gram per centimeters cubed. Okay. So it'll sink if the density is greater than 1 gram per centimeter cube, and it'll float if the density is less than 1 gram per centimeters cubed. So will this sink or float?
Both. It'll sink and float.
It can't do both.
It can float.
It's going to sink. If it's floating means it's floating on the water. If it goes into the water, it's sinking. So it doesn't have to sink at the bottom. What's that?
How come, like, if we're going to swing to float?
Because of the mass. So your density, even though your volume, so the size of you. So even though your weight is more than the water, because you take up more space, and especially if you're stretched out, you take up even more space. That's why you would float. Also, muscle is a higher density than fat, so a person who's more muscular has to work a little harder to float. Somebody who has a little bit more fat has an easier time of floating. So polar bears, they float fantastically because they have such a high percentage of blubber.
What about
Dead, it's probably going to eventually sink because it's going to get waterlogged. Is the problem. So interesting conversation for those who are listening. All right, so here our density is greater than 1 gram per centimeters cubed. So the what was this thing? The cylinder. The cylinder will sink because its density is greater than the density of the water. Let's see if I can move this up a little bit. One number at a time, huh? Then the density of the water. Okay. Any questions on this? So this one was a multi-step problem. We had to solve several things on it. And you also had to interpret the information. 142 we get out?
Yeah, quite frequently. Usually. What did you say? I thought you said James. No.
So this one is in the notes. It's after the problem of the density of a rectangular prism. The two must be switched on the notes. All right, so we want to find the density of a rectangular prism measuring 3 centimeters by 4 centimeters by 6 centimeters. No. So here we'll draw out our picture. So it really doesn't matter on a rectangular prism which dimension is which. So 3 centimeters I'm going to put here, 4 centimeters I'm going to put here, and I'm going to put 6 centimeters as the height. Let's find the area of the base. We'll make the bottom the base. So the picture helps you with figuring out what to do. Purple 1, how do I find the area of the base?
3 times 4.
Yep. So we have 3 times 4, which gives us a base of 12 centimeters squared. Our volume is going to be the area of the base times the height. So our volume is 12 centimeters squared times 6 centimeters, which is going to give us 72 centimeters cubed. So we have the volume. How about our mass? Purple 3, what was the mass?
Mass was 7.9 kilograms. Okay.
Right, and so now let's set up the density. Anybody at the orange table?
Is 7,900 grams.
We can leave it as kilograms, it's fine. I mean, you can change it to 7,900 kilograms, but we can have the units be kilograms.
Over 72 centimeters.
Right, so yeah, you can make it 7,900 grams. You can leave it at 7.9 kilograms. I would change if it's a multiple choice question. You see all the answers are in terms of cubic centimeter, grams per cubic centimeter. You want to change it, but otherwise, it really doesn't matter. So just a reminder that density is the mass divided by the volume, and then if somebody could simplify that for us. What is it again? 0.1097, and this is kilograms per centimeters cubed. Right, now it would matter if we wanted to figure out whether this thing would float or sink, right? Because we have the water density is in grams per centimeter. So what if we wanted to know would this thing float or sink? So we'll kind of add to this problem. Float or sink. So right now we can't really compare because the units aren't the same. Right, so we could change though kilograms to grams. How many grams is 0.0197 kilograms? No.
109.7.
Okay, how many grams are in a kilogram, guys? Let's think.
So how many times do you have to move it over?
1.097.
No.
No, 1,000.
There we go.
Oh, wait, yeah. 1,009.
So our density, if it would move over 4 decimal places, right? Because there's 1,000 grams in a kilogram. So 1,097 grams per centimeters cubed. So sink or float? Yeah. Definitely gonna sink. I don't know what this is made out of,
Today's National Science Day.
but that's a pretty hefty amount of weight there.
What are you trying to say?
Someone say go back? Well, yeah. I didn't put this problem in your notes, but I'd like it to be in the notes. So let's have you write this in your notes.
Can we do the back?
Yeah, you could do the back on the back. There's all that space on the back. So I write the problem, and then I'm just going to go right to the closing after that. And I don't need to continue the podcast. So thanks for watching. You at home, you write down this problem too.